is coming. There we are. Now we're on the recording. So we'll run about an hour for a feature presentation or so, depending on what Jon does. And then after that, we'll turn off the video. And that way, nobody's got recordings of us drinking beer and socializing and having fun. And that really is intended later on in this one to be the interactive part of this whole thing, where you guys get to talk to us and you can ask us questions or laugh at us or do whatever the heck you want. So hopefully that should be entertaining. I know Jon's really looking forward to that part. So, all right. Big thanks to the sponsors here, Excel Guru, my company, for hosting this, putting together. Microsoft for helping us out, as they always do, giving us lots of good content to talk about and giving us access to some of the cool pieces that we get to play with. Also, thanks to SkillWave, which is the training division that goes with Excel Guru here. If you're looking for training on business intelligence and Power BI and Excel, please check out our website. We've got all kinds of really good stuff up there we're really proud of, and we would love to help you build better business intelligence. So that is our goal there. The next meetups that are coming up in our Excel track, which is going to be next week, we're going to be, or sorry, Power BI and Excel track. Next week, we're going to be doing this a week early. We've got Scott Helmers coming. He's going to be talking about data analytics in Visio. So this is going to be kind of an interesting and different look at things we haven't had before. So that's going to be kind of cool. I'm looking forward to that. And then in January, I've managed to snag Wynn Hopkins from Perth, Australia. So we're going to be reaching way far afield. And Wynn is going to be giving us a what's new in Excel. And this is going to be kind of interesting because I don't know whether or not everybody actually saw this or not, but today there was a big announcement on the tech community blog that the Excel group has now released to beta the new Lambda functions, which means you can actually create your own functions in Excel, basically user-defined functions, without writing any code. So we'll make sure that Wynn gets to talk to us about that. I'm sure he's going to be super excited to know that's on his to-do list. Hey, Jon. Coming up in February, there is a Global Excel Summit that is going to be out of England, but it is actually going to be streaming live here. If you would like to attend one of these, you can actually get 10% off with this particular coupon code here. This deck, if it's not already, will be PDF'd and put up on the Meetup site, so you can always grab that code from there. Just keep in mind the early bird pricing on this does end just before Christmas, so you'll want to jump on that. There's a ton of great speakers that are going to be involved in this. Even though my face is not on this list, I will actually be speaking there as well. So that should be a good time, good fun. Just a quick shout out to PASS. If you're interested in joining the PASS organization, you can do that here as well. And a couple of other things I just want to throw out. The Excel team is actually trying to conduct some surveys to find out what people love out of Excel user groups. And if you're interested in actually filling out that survey, please go here and fill that out. They'd love to hear from you what you like about the user groups and you know how often you go to them, which ones you're part of. So please fill that out if you can spare 5 minutes, not even that, a couple of minutes to fill out those questions. Finally, speaking of surveys, if you would like to speak at our user group, we would love to have you. Please go here, fill out this nice little survey here. We'll get in touch with you. It can be around Power BI. It can be about Excel. It can be about both. It can be about things that tie into these things. We're always looking for speakers. I believe we've got our lineup all the way through to February right now, which is great. But after that, of course, you know, we're still looking to bring people in. So if you'd like to try your hands at a speaking slot, even if you only want to do a 15-minute or something like that, we would love to encourage you to do those kind of things and, you know, add your take on what's going on. I mean, that's what we do with this. I mean, it's where Jon and I both spend our time, but we'd love to see more people sort of enter this sphere. On that note, I am done with my preamble. It's 6:05, so Jon, I'm going to hand this one back to you. I'm going to stop sharing my screen. If you want to take over again, it is your floor, my friend.
Okay, let me just find the right screen. You see Excel showing there?
I do not. You're going to need to share your screen with me. Oh, here it comes. Yes, I do.
All right.
You are good to go. One question, Jon, I wanted to ask you quick before we actually set up. We didn't actually cover off on this one. Questions in the chat. Do you want me to interrupt you and let you know that they're there? Or would you like to just watch the chat yourself and monitor it, or save them to the end? What's your preference?
I always say I'm going to watch the chat, and then I never see it until the end. So I guess if someone has a pressing question, they can try to put it in the chat, and Ken, if you can keep an eye on that. Otherwise, I'll be glad to stick around until, whenever and talk about these things. And it's really sort of an introductory view of the topic, and so hopefully we won't need too many questions. If there's a problem with,
I'll interrupt you if anything major comes up, though, and we'll let you go. Outside of that, floor is yours, bud.
Great.
I feel like I lost your audio, John.
Look at that. Oh, you know what I did? I turned off the camera just so I wasn't using so much bandwidth. Thanks, Ken and Excel Guru and the other sponsors. My name is Jon Peltier. I've been an Excel MVP for pretty much as long as anybody nowadays, and I've been doing Excel for working with data and charting data for a long time, and I guess I've become kind of the go-to guy for Excel charting. And usually my talks are all about just charting stuff, but I thought, let's look at some ways of looking at data that involve charts, but they involve some calculations and some statistics. So I call this thinking smart graphically and statistically. And the name of the topic is statistical process control. It's a way of looking at all kinds of different processes, and maybe I'll think of some examples as I go along. So I'm going to just start out and remind everybody, why do we bother with charts in the first place? And this example, as well as a lot of the techniques that I'm going to show, come from a book by a guy named Don Wheeler called Understanding Variation. And if I knew where my copy of the book was, I'd hold it up. It's somewhere in my office, but it's a bit of a rat's nest these days. But so he shows in his book, he says it's even now, and I mean, his book came out 25 or 30 years ago, but even now, it's not uncommon to see just a monthly report or an annual report, and it just has a table of numbers. And you look at that table of numbers, I mean, it's not even really a table, it's sort of like a list. And you look at that and you say, well, nobody can see any pattern in those. So, you need to tabulate the data better. And so here what I've done is I've taken his numbers and I've put them in a list, and I've made up some, since those were
John,
weekly.
I think
yes.
we lost your screen again.
You lost my screen again.
I believe so. Can you reshare your desktop for us?
Yeah, look at that. Everything was working fine while we were just sitting around and talking. But
it's always the way. You forgot to sacrifice a beer to the demo gods, I think.
Well, I got a whole, like I said, I got my growlers filled earlier today, and so we'll be sacrificing them later. So I don't know how much of this you saw, but if you have numbers that are just kind of thrown here, you don't really have context for them, and you can't really, make sense out of them, visually. And we're visual people, well, I'll get to that later. But so here what I've done is I've taken the numbers and I've given them, typical week ending dates. And I apologize that they're last year's dates, but it's too hard to find ones that match. And so you still can't really make sense out of them. I mean, I can see it goes from May until September. And I'm sorry for those of you that don't like the US date formatting, but Excel does that automatically for me. So anyway, when I teach people how to do charts, I tell them, insert menu, come over here, and you see the line chart, and use the one with dots so you can tell where the data really is. And so now here's a nice line chart, and now you're starting to see a pattern, which we couldn't see just from the numbers. But we grew up on the savannas in Africa, and we had to be good at detecting patterns because, you never knew if that was just some trees or was there a tiger in there ready to eat you. So we're really good at detecting these patterns now. And so instead of everybody watching me while I neaten up that chart a little bit, I'll just click to the next slide. And here you see very clearly what's going on is we're puttering along at a certain level of production. Maybe this is how many units of, widgets that we make. And then the last week of the month, the factory has to go all out just to meet the monthly quota. So right there, we've learned something about the operation of our factory just by looking at the data. Without looking at that, we wouldn't have noticed that there's a variability in our production during the course of a month. So what I want to do is now, how do you analyze these data points as they're coming in? And so I'll start out here, and I don't know, maybe what we're looking at here is some kind of production cost for a certain product that we're manufacturing, or it could be maybe the cost for our shipping department every month, or you can apply this to anything you can measure, really. So January, we plot our first value, and okay, we don't know much about that yet, but so that's fine. So we plot another value, went up a little bit, but that's okay. We plot another value, it went way up, and it's like, oh my God, this is terrible. We got to have meetings, we got to sit around and punish people because look how bad it got, and things have to change. And then the next month, oh, it went way down. Hey, this is great. We all went out for beers and pizza and celebrating the great performance. And then as we start collecting more data, we see that there really is kind of a lot of variability in the data all along, and this little control there is a little flaky. But now you look at it here, and you see that we got all excited about, oh my God, look how terrible it was. Our cost went up, and then it went way down, and we got excited about that. And now we look at it, and we see that really it's all part of the same variation in the process. And that's sometimes referred to as the voice of the process. It's it's not the same exact numbers every month. It goes up and down because of what are referred to as common cause variations. And that could be related to seasonality. The cost goes up in the winter because you have to heat the factory. In the summer, you have to air condition the offices. You have to mow the lawn. There's things like that. There might be differences in materials. If you get your materials from different suppliers, there might be cost differences. There might be problems with delivery from certain suppliers. Some of them that might not be as good quality, so you're rejecting parts. And then personnel, that's another source of common cause variation. And you can, just think about it. What else could affect the process? And so really there's a bunch of tools that you can use instead of just plotting it like I did here and scratching your head and freaking out when it gets bad and celebrating when it gets good. What we're going to do is, well, this is a simple timeline. A timeline is just plotting any data against time or against some kind of sequence. And what I've got here now is the same data, and now I'm going to call it a run chart. And to add a little bit of statistical rigor, and this is kind of the first thing they did decades ago when they started looking at these processes, they plotted the median value. Median because it's easy to calculate. You just find the middle value, and you put it on your chart. And then some people were thinking, well, how do we know if that's good or bad? And so what I'm going to do is show the runs. And it's called a run chart because there's runs. The run is basically just a sequence of times where the data is on one side or the other of the median. So you see the first run started at the first point, the second run started down here, the third one up here, and the fourth one, and so forth. And you see in this set of data, there's 24 points. We had 12 runs. Is that high? Is that low? Off the top of my head, I don't know. There's tables you can go and you can look up what is the expected number of runs you might see for this many data points, and probably for 24 points, it might be somewhere between I don't know, 6 and 18 or something like that. And if it's more than 18, it means it's up and down too frequently. And that means maybe there's something wrong uh, with your process. It's not operating by the usual amount of randomness that you see in the common causes, seasonality and so forth. So the run chart is kind of a quick and dirty way of looking at it. But there's other things we can do. Instead of just a median and so forth, we can be a little bit statistical about it. And what we'll do is we'll make ourselves a control chart. So it's the same data again. But what I'm going to do now is I'm going to plot my average. And so it's almost like the run chart with the median. The average actually in this case is slightly higher than the median, but both of them are generally reliable measures of the middle of the process's results. And now what we're going to do is add control limits. And I'll just check the box here to calculate them. And you see we have control limits here. They're pretty wide. The control limits that I'm using here are just simple ones, and if you've done any statistics, you might be familiar with it. It's just the mean plus or minus 3 times the standard deviation of the measurements. And you see that we're within that plus or minus 3 sigma of the center line. We haven't varied too much from there. So really, we shouldn't have been very excited at all about any of the results we saw. We shouldn't have freaked out when we went way up in March and in April. We shouldn't have celebrated. Even in July of the second year, that's not enough of a reduction to really matter. The process was just tooting along just fine without anything else. So here, the standard in industry, at least once everybody got color monitors and so forth, has been to use green lines for the center line and red lines for the control limits, or also called process limits. And I just like to point out, in this case, it doesn't really matter because the green line is always in the middle and the control limits are at the extremes. But green and red are not colors that are good to put together because, certain fraction of the population, something like 8% of the male population, has trouble distinguishing green from red, and they might not even know it. A better color scheme I'll show here uses blue for the center line, or blue for good, and this is the orange for not so good, or for the control limits. And if you look at any of your color little flyouts here, that blue is just the first of the accent colors in the default Excel palette, and the orange is the second accent, so it's easy to find them. You see in the waterfall chart that Microsoft introduced, I think in Excel 2016, they use blue for up and orange for down, and it's a reasonable sacrifice to make for the people that are have color vision. So we talk about plus or minus 3 sigma, and this is just a simple normal curve. It's a Gaussian distribution, and it's actually is good for measuring variation, because even if the distribution itself isn't really a normal distribution, it's a good approximation to the kind of errors that you get from different common causes. And so if I just look at this, we'll see that plus or minus 1 sigma, about 2/3 of the data falls within those limits. It's 68%. And plus or minus 2 sigma, which includes now the blue, the green regions here. And if you're colorblind and can't tell blue from green, sorry about that. But that now includes 95% of the observations. And plus or minus 3 sigma is better than 99% is included in that. So if you set limits of plus or minus 3 sigma, you don't expect to see too many violations of your control limits. Yeah, you'd expect something like 1 in 400, or I forget what the exact number is, but it's not too many. So it's you know, 0.25% of your measurements should be outside of the 3 sigma limits. Let me just pop that up. And so there's my 3 sigma. That's why we use 3 sigma. But using your standard deviation of data sometimes can give you skewed results if you don't have you know, large size population. 1 or 2 funny results can give you you know, unreliable limits. So we're going to use a little different technique here, and it's referred to as an IMR chart, which really it's 2 different charts. It's an I chart for individual values, and it's an MR chart for moving range. And we're going to use the moving range to compute our limits instead of the standard deviation. I think part of the reason too is when they were building this methodology, there's a lot of calculations in standard deviation. They didn't have Excel yet. They didn't have computers yet. They had to do it all by hand. So the moving range was a lot easier to get a handle on. So first thing I'll do is I'll calculate my moving range. What moving range is just how much each value differs from the previous value. And we do it in absolute numbers. So they're always positive. And we don't have a moving range for the first point because it was the first one. We can't subtract it from the other one. So we have a column of moving ranges here. We plot them on our chart, and then we calculate our average moving range and plot that on our chart. And you see I've used blue here instead of green. And now we do want to get our upper and lower control limits for our individuals chart, but we also have an upper control limit for our moving range chart. And that looks like this. And what that number is, you see it's shown over here. You take the average moving range, multiply it by 3.27, and that's what you use for your control limit on the moving range. And so if you have any moving ranges that are above that, you know that there's something going on. You know there's some violation of your assumption that it's only common causes in the process. So that's fine. Now I'll come here and I'll show my average of my individual values, and that's the same as it was before. And now I'll show my control limits. And what the control limits here for the upper and lower process limits, you take the mean and you add or subtract 2.66 times the average moving range. Instead of 3 sigma, it's 2.66 times the average moving range. A lot of statisticians that know a lot more about math than I do came up with these constants, and they give numbers that give you the same level of confidence of these limits compared to using the plus or minus 3 sigma. If I go back to my other one, just watch how much these limits move when I change to the plus or minus 3 sigma version. They don't change very much. They change by about the width of the line, and so and you know I've looked at it myself. I've run some simulations where I've looked at like 50 different samples of data and seen how the numbers change. And as long as the data in the chart is normally, the variation is normally distributed, the moving range and the sigma standard deviation based limits are all pretty close, like a few pixels apart, a few units. On this scale, it might be plus or minus, 3 or 5 units, which really, if you're just using it to monitor your process, that's good enough. So,
hey, John, quick question from the chat for you.
Yes.
Carlos is asking if you can share some real work applying statistical process controls, charting. Do you have some examples where you've done this in the real world?
Yeah, I've done it in the past a long time ago. You might use it for, well, in fact, I wrote a blog post. I think that file I even still have open right now. I wrote a blog post some time ago, and where I was talking about using uh, statistical process control to monitor my weight. And what you see here are IMR charts of my weight. And it's a little bit complicated. I'll talk about some of these things further on. But so I started, well, the reason I got interested in this, a couple of years ago, I went on a diet and I lost like 40 pounds. And now it's like, let's see how my weight, you know, is it a stable process? My weight is a process just like anything else. And so you see how I've charted it here, and you can see that there's some points that are a little bit below the line. There's some that are a little above the line. These might be instead of the common cause things, which are just the random fluctuations. Well, let's see. These two dots right here that are high, those are special causes. One of them is the day after Christmas, and one of them is the day after New Year's. Obviously, we do a lot of celebrating those days, so your weight goes up a little bit. And then we got locked down somewhere in this vicinity, and I was not going out to eat. We were watching what we were eating. We were being careful about going to the store, and I started exercising more, so my weight went down a little bit. And that was this other part of the process. And then, I can explain what has happened and different things that made the process change. But so that's one example. You can use it to look at any kind of business processes. I've seen it looking at like shipping costs, how they vary from month to month or from week to week. Things like the time it takes to process forms, like requisitions, for example, or things like that. And it's used very commonly in manufacturing. You might look here at the number of parts per hour, or the number of defects you get, or anything you can measure, like the diameter of the parts that you're producing. You have a certain target and you want to make sure they fall within limits, because these parts then go into larger units and they need to fit. So it's very flexible that way. And in fact, there's times where I'm just doing this with simple individual values here. And these are IMR charts. There's also like X bar R charts, where you might have 5 samples that you're sampling. So it might be each shift, they make 8 parts. And so you're looking at the average of 8 parts. And then down here, instead of a moving range, you're looking at the range just within those 8. And there's other factors here. It's not going to be 2.66 if you have 8 parts. It'll be some other number. But okay, so I'm getting rambly here, which I tend to do. So we know, I already said that if a point goes outside of those limits, that we know not necessarily that something bad, but we know that the process is not strictly following the normal variation. And there's some other rules that you can use even when you haven't exceeded your control limits. So I'll start developing that here. So you remember my 3 sigma plus minus 3 sigma, and the different the colors that I applied, for how far from the center line you are. What I'm going to do is I'm going to put my charts here again. And so my individuals chart, I said that these were plus and minus 3 sigma away from the center line. Moving range, it's not really like sigma, that you don't have a lower control limit. But anyway, so let's first look at the individuals chart. I'm going to highlight it, and I'm going to put my sigma bands to match the colors of the bands in my nice normal curve here. So you see I have 3 bands above and 3 bands below, and they're labeled A, B, C in the opposite order than what was intuitive for me. But in the old days, I guess they thought A, B, C going inwards worked, and that's fine anyway. And then we'll mark the same bands down here, just 2 bands, one for below the average and one for above up till the control limit. And then there's sets of rules, and these are the types of rules that there are. One of them is beyond limits, so that that just means it's a big variation away from where the process should be, and that means if you're outside these these orange dotted lines, that's and you just need 1 point out there to signal a change in your process. And then this one, I call it zone A. That's kind of a large deviation, but not a huge deviation. If you have 2 of 3 points outside 2 sigma, above or below, and actually on the same side of sigma. So if I have 3 points, 2 in a row or 2 out of 3, then I should signal that. I should indicate that something went funny with the process. Smaller shifts, if you have 4 out of 5 in a row that are in the green or the blue zone on either side of the center line, on the same side of the center line, that means that you have some moderate amount of deviation. Another thing is if you have 9 points on the same side of the center line, you don't expect to see that. The numbers in these rules, they were chosen to reflect about the same probability for each of these violated. So the probability that you'll have 1 outside of the control limit, you'll have 2 that are outside of 2 sigma from the center line, and so forth. So 9 consecutive points on the same side of the center line, or if you have a trend, if you have 6 points in a row that are moving in the same direction, up or down. If you have a mixture, that means you have 8 consecutive points that are outside of the 1 sigma, but on either side. And that could mean, you have some segmentation. It might mean that you're looking at results for 2 different operators of a piece of equipment, and one of the operators cranks down the knob very hard, so his numbers are up here, and the other operator is looser, so his numbers are down there. So you see, actually, it's like 2 different populations. Over control is if you have 14 points in a row where you're alternating directions. So what that means is the process isn't running by itself. Maybe the operator looks at one, he says, "Oh, that's too small," and he cranks the dial. "Oh, that's too big," and then he cranks the dial back the other way, and you get a zigzag kind of approach. Another one is called stratification. I'm not sure exactly what that word means in this context, but it means if you have 15 points in a row within that blue band and none of them outside of that, you don't expect that either. You expect a little more variation. So as many of these rules as you want, and if you violate any of them, that means you have to go look at your process. That means you don't have common cause variation, you have some kind of special cause going on. And whatever that special cause is, it depends on what the process is, and that's why you have to get all the smart people together to think about it. You have a smaller number of rules for the moving range chart. But again, it's you exceed the limit, or you have 9 in a row on the same side of the center line, or you have a trend where 6 in a row are increasing or decreasing. It might be good if you have 6 in a row that are decreasing variation. That might mean that you're fine tuning your process. But then what that means is then you have to recompute your limits once you've fine tuned it, so that you know if you violated the new process. Over control if you're alternating up and down too much. So those are the rules, and then how do we indicate them? Well, I'm only going to indicate them for the 3 sigma rule. But we look here, we have a point that's outside the dashed line. we want to indicate that somehow. So what usually you do is you give it a different marker, you color it red, or you do something to highlight it so that somebody can just at a glance look at this and know that, oh, there was a violation there. And you know, if the problem here, you know, if this is our shipping costs during a month, we might look here and say, oh, our main shipping supplier went on strike and we had to pay extra to get another company come in. Or you know, you have to look at what happened. It's a special cause. You know, it's not, that variation isn't dictated by the same thing that is dictating this other variation through the process. It didn't jump up enough that we saw huge moving range changes, but it still showed up in the individuals, and we showed our indicators. Here's another case where we actually had moving range violations. And, you know, if we show the indicators there, this point is just barely under control, but because we were a little bit higher than the center line and we dropped way down and went way back up, there we have 2 violations of moving range. And again, this might be our shipping costs went down. Well, maybe because in May, you know, because of COVID, we had to shut down our factory for 3 weeks, so we didn't spend a lot of money on shipping because we weren't making anything to ship. And maybe in fact this number is higher in April because we knew that was coming up, so we worked a little harder to, you know, get stuff out before the shutdown, and then we were trying hard to catch up afterwards. But again, when you see these violations, you have to go back and look at the books and see what was happening at that time. It's probably some special cause that made it happen, and the special cause made this point come down. Even though it didn't violate the rule, it still indicates that it could happen, or that it was a special cause anyway. So, and now the other thing with these points, when the moving range, when you have a couple of high points like that, what that does is it really skews your control limits because it makes the average look higher than it really is. You know, if these are abnormally high, I don't want to include them in my average. And what that'll do is it'll bring my average moving range down. It'll bring my moving range control limit down. And it will also tighten the control limits on my individuals chart. And let me show you how that works. You see, I have 2 points up here which exceed the moving range control limit. What I want to do is exclude those 2 from the analysis. And, you know, so what I don't want to do is take them off the chart, but I'll use a different marker. I'll use an X to exclude, to show they're excluded, and they're not in the chart well, they're part of the chart, but they're not part of the analysis anymore. I've excluded them. They're not included in the average. So now, and in fact, you see the control limit went from, what's that? That's about 80 and 79.2, and then it dropped all the way down to under 60. And also my control limits on my individuals chart changed enough that this individual point that was just on the edge of being a violation, now it is a violation. And if I want, I can exclude that point from the analysis, and it might, you see, my average here is a little bit below 100, and I know we're trying to get 100. And when I exclude that point, you see we're back up to 100, and we have our tighter limits and everything. And the whole rest of the process looks just fine. I have another example here where...
Hey, John, quick question for you from the chat here. Derek has asked, how many data points would you usually have for a new process before you start actually applying your analysis?
Yes. Well, it depends on how many... okay, it depends on really how many points do you need that you're confident in your estimation of the variation. And you know, I have a colleague that tells me that, you know, you shouldn't try to calculate a new standard deviation until you have at least, I don't know, he's always telling me some number and I just never listen to him, but it's like 12 or 15 points. Now I'm going to show you in a bit what it looks like if you have two different processes on the same chart. Like up to a certain point, you have one process, and then something changes, and then you have a different process. And what you could, well, and I'll talk about it when I get there. But so what I'll do is I'll show here. I see here I have one point that's violating my control limit, and through the magic of conditional formatting, I know that it's this cell right here. So I'm going to just put an X in that cell. And so what happened there is it dropped my upper control limit enough that now I have another point that's in violation. And I'll put another point there. I'll put another X there, and my no, control X doesn't do it. It's sometimes sometimes you gotta switch to another screen and then back. Yeah, there we go. It's like what happens sometimes is I get an invisible window in front of Excel, and I can't click through it to the sheet that I'm looking at. And I have to switch to another sheet and then switch back. And I don't know if I'll be like everybody else and blame the new interface where every sheet has its own window. I don't think I'll do that. But see, now when the second one has been excluded from the analysis, now my limits have tightened up enough that I have another point here, and maybe I want to exclude that, or maybe I don't. Maybe I want to just show that because I want my boss to understand that, yeah, we did drop here, and if it was because of the plant shutdown, then at least we know what it was. So one more exclusion here, it's just this point up here we're excluding from the analysis, but we're keeping the same moving range calculations because they were all within limits and so forth. So the question before was how many points do you do if you're changing your process? And actually there are some processes that change all the time. Like it might if I'm looking at something like airline passenger traffic or something, up until this year, of course, that was increasing steadily, and you wouldn't want to fit a flat set of control limits like this. So what you have is data that itself has a trend like this. And if you plot this with just the normal control limits, you see you're violating the limits at the beginning on the low side and at the end at the high side. And this is the kind of process that really what you want to do is fit a trend. So instead of using just a constant value for your average, what you would do is do a regression and use your line of best fit as your center line. And then your moving range would be just the relative difference of the points from the center line. And that looks like this. Conceptually, it's easy to do. The math isn't much harder than what it was for the horizontal lines, but it helps you visualize how your process is varying when the actual outcome of the process is expected to be varying. So that just shows a little bit about the flexibility of this kind of process. This next example, which actually is my last example, I'm starting here. My process is all the values fall around a certain mean. But what if my data? What if there's a change in my data? Either I have purposely made a change to my process, or maybe just something changed. I changed the supplier of something, or I bought a new piece of equipment that can spit out more widgets an hour than my old equipment, or whatever. There's there's something going on here, and we can see that I have a bunch of points in the first half of my data which are below the lower control limit, a bunch that are above the upper control limit, and look here, right in the middle where we switch from one to the other, we see our moving range is a violation because we went from kind of one set of data to a different set of data. And so we can fit that using a staged fit where we just set it up so that we have stage 1 and we have stage 2. We don't bother counting our moving range for the first point of the second stage, the same as we don't for the first point in the whole analysis. And what we see is, in this case, the average moving range, the first half of the data, the first process, is a little bit lower than the average in the second. And so our control limits are different between the two. And if you squint real hard, you can see that the control limits on the first half in the individuals chart are tighter than on the second half. If you don't have enough points that you're confident in your different calculations of your variation, what you can do is, instead of calculating a different average at the beginning and a different average at the end, what you can do is just average the values you have and just use the same assumed variance for both parts. And if I were tracking my weight, I would assume that my day-to-day variance is probably going to be due to the same common causes before and after a change. I mean, the change might be now I'm exercising more, but other than that, the variation is how much I eat one day or things like that. The variation would probably be about the same. So I might be tempted to use the same variance for all parts of the process. It's a kind of thing that, when you have a little experience with your process, you can make that judgment. But again, I mentioned that I have one colleague who, and he's done a lot of this stuff. He does a lot of training in this stuff, and he says you should probably use one variance unless you have 20 or 30 points in each separate segment. Whereas I was introduced to another guy who also has a lot of experience, and he said, oh, you should never use the same variance. You should always calculate a new one. And I said, what if you only have 3 points over here? It's kind of hard to calculate a standard deviation. He says, well, yeah, whatever, but you should always calculate a separate one. So, all right, so that's as far as I've gotten. Maybe Microsoft has wide control limits on monthly product feedback. Well, once I found the send to frown button, their amount of feedback went way up. I'll say that. So
I know this is so true.
But they know me by name now, and it's funny because a couple of years ago I was at Microsoft and I was talking to one of the program managers, and he's saying, well, thanks for sending all the feedback. I use VBA a lot, and I'm always crashing Excel because of crazy stuff I try to do with VBA. And as soon as it crashes, I collect all the dump files and so forth, and I upload it to OneDrive, and I send a frown, and I attach a link to the UpDrive folder, and I said, here's what I was doing. It broke. Please fix it. And so anyway, he's talking, and a couple of guys go walking by, and these are the engineers that actually do the real work on Excel. And so this guy introduces me. This guy's name is Prash. He introduces me to Jim and another guy who are the engineers. And Jim says, oh, this is the guy that sends us all those bugs. Hey, glad to meet you. So it's pretty funny.
Yeah, John, I just want to say, Dave had actually made a comment in here when you were talking about that weird effect that you get where you got to switch away from one workbook to another. And I mean, my comment back to him was like, look, I mean, when you get this, send in the frowns on this for two reasons. Number one, the more data point that Microsoft gets, the more likely they kind of fix it. And number two, that way it's not just Jon sending in bugs, and they'd love to hear from other people too.
Yeah, I mean, they know I find all kinds of weird, strange things because I'm always working in the dark corners of Excel, and doing things that other people know better than to do. But it's cool, and so I dig in there, um, and I send in a lot of stuff, and I've helped them fix stuff. I had this weird thing where um, things were crashing, and it's like I would close a file and Excel would just crash. And it turns out it was some interaction with, I was using Dropbox to synchronize some files. And it turns out if I had a file open in Dropbox and I closed another file, Excel would get confused and think I had closed the last file, and it would shut itself down. And it was some glitch, and because it happened to me enough and I was able to reproduce it, they were able to go to Dropbox and say, you guys are breaking Excel, and they got Dropbox to fix their own code.
Yeah,
so
this is always the piece with this. I mean, the more that we try and encourage people. I mean, for sure, to use those feedback mechanisms to send things in. I mean, include your email address if you're willing to do it, because the engineers will reach out to you and say, look, I mean, you know what, we're trying to track this. Like, we have a lot of data points. This is happening, but we need some more information. Would you be willing to work with us? And I usually ask when I'm teaching a course how many people have actually encountered a bug inside Excel, and most people won't bother putting up their hand, or they say, no, I've never found a bug. I'm like, you know what? Yes, you have. You've hit something. You just don't recognize that that's what it is. I mean, all these weird things that happens when Excel crashes, that's a bug. There's something happening behind the scenes. And if we can get that repro case, we can get it in there, they do fix them. And that's the beauty of it. I mean, we give Excel a hard time over the fact that it's unstable and whatever else. But believe me, it would be a lot worse if it weren't for the efforts we make on this.
By itself, it's pretty stable. It's just that, I mean, I'm pounding the hell out of it all the time. Yep. And Ken was joking with me at the beginning because I had a lot of workbooks open. Well, I had 3 or 4 open, which for me is not a lot of workbooks. It's like, how many windows is too many in Chrome, right? 30? I don't know. And so maybe I'm stressing Excel because I'm doing that, and because I'm playing funny games with UDFs and using undocumented features. Like there's UDFs. You write a UDF and it only returns you a value. It doesn't do anything to formatting or whatever. But you can write a UDF that will change properties of charts and shapes. And it's not supposed to, but it does. And it's been doing it for a long time. So we've figured out ways that I'll write a UDF that looks at this column of numbers, and it'll calculate what limits I should put on my axis, and it'll do that using a UDF, which is really kind of cool. But I discovered that if I have a lot of form controls, like that slider that wasn't working right on one of those previous worksheets, if I have a bunch of those and I have the UDF, when the UDF calculates, Excel will crash. And I sent them a lot of crash reports about that, and I just couldn't afford to wait for them to fix it, so I ended up using a different approach to rescale my axes. But anyway, I've gotten really into this whole protocol lately. I have had one client who has his own software package that does this kind of analysis, and I've recently gotten another client, and we're actually building a VBA powered workbook that you can enter your data, and you can get you can get control charts, and you can put stages in the data wherever you want. You can say, I want this stage to be linear, I want this one to be flat. You can even use an exponential fit instead of just a linear fit to your data. And I got to test that out in the early stages of COVID, where things were growing exponentially, and Um, I did a lot of testing of COVID stuff. Just looking for, you look at your daily um, reports of how many infections there were, and those jump around a lot. So yeah, you can average them, but what you can also do is you can just see what limits they vary between. And people are saying, oh, it's getting better, it's getting better. Well, if I don't see that point getting below that line, I'm not going to say it's getting better. There's no statistical basis for it. Um, and so anyway, that's one of my business activities is software. I write plugins for Excel. I've had plugins that make charts that Excel can make, but it's very hard because you have all these steps, and I basically, my software is a bunch of buttons that does this for you. And
which you haven't shown off yet, John. How come you haven't actually called out your software?
I really haven't, but this is what the ribbon looks like. There's a whole bunch of different stuff. One thing I was showing Ken before, the same way that Microsoft has feedback here, and you can, when it comes up, you can send a frown or send a smile. I do send a smile once in a while, like if I discover some new feature that I didn't know they were working on, but I probably send them an awful lot of frowns. And this is where it is. You go to the help menu. It used to be buttons up here. It was easy to get the smiley face, or it used to be a smile and a frown. And then they changed it so it was just a smile, but it brought up this window so you could just click on the frown anyway. And it's here under help, feedback, and whatever. Well, I decided that was a good idea, and I put that here. People can send me a smile or a frown or a suggestion, or they can ask a question. And people haven't really taken to this too much. They just send me an email, whatever. But I have a whole bunch of different types of waterfall chart that it makes. I can make box plots. If you do any statistics like this, what some people will do to help analyze their data is they'll make a box plot to look at the distribution of the points about the center line. All kinds of different charts. And so forth. And then other tools like edit formulas. You ever have a whole bunch of charts on a page and they go from row 2 to row 25, and you added a row of data and you hadn't had the foresight to put it in a table or to define custom names? I have edit formulas, which basically is like find and replace for all those series formulas. And you can pop this up and say, well, I want to change 25 to 26, and it's really not going to do anything here. It's going to give you a little blank thing on the edge, but I'm going to change, I can change just the active chart. I can change all the active charts on this sheet. I can change everything in the whole workbook. And so I do that, and you see here's my added row there. And see, that was finding all these different formulas and changing them, or finding every highlighted section. And you can also do it by dragging these highlights around. If you ever want to take one of my classes, I show you all these tricks. I teach classes, which is another thing I do. Or a lot of times making charts can be a real pain. So, I have a chart and it's got 3 series and I want another series. I can just click on this add series, and if I've selected a series already, it'll just go and like say somehow I lost that data. I can click on my average and or actually I'll click on my lower one because I deleted the upper one. I can go add series, and it adds it up here, and it was painless, right? Now all I have to do is format it, and if I want to format it, I click on that, I copy my series formats with that button, and I select the other one, and I go paste the series format, and look at that. Was that easy or what? And just a lot of tricks. If you have a lot of charts you need to export. Back when I still worked for a living, when I was an engineer, I had to do monthly reports, and each monthly report I had 4 Excel charts that had to go onto a PowerPoint slide, and then I had probably a dozen slides in each report, and it was really tedious to select a chart, copy it, go back to PowerPoint, paste it, come back to Excel and copy it, go back to PowerPoint and paste it. And this is before I did a whole lot of Excel programming, VBA. And I figured out what I needed to do to select a bunch of charts on the Excel sheet, click a button, and by the time I got to PowerPoint, they were already pasted in the slide, and I just had to arrange them. And so that has turned into some of these chart to PowerPoint things. Just a lot of tricks that make charting easier, make working with charts, make formatting charts easier. I have a simpler one I call Jon's Toolbox, and I use that like if I need an example chart because I want to demonstrate something, I click here, and here's a data range, and I have a bunch of different charts, and they're my own personal favorite formats. So if you make a column chart in Excel, you come over here, you find your column thing, and you do a column chart, and here's the Excel native one, and that's okay, right? But you know, maybe I have my own favorite, so I come over here. My column chart looks like this. You see, I don't have the little space between each bar, and I have a little smaller space between the groups of bars. And you know, it's just my preference, but that's how it is, and how it always makes it that way. Or for example, if I want to make a bar chart, bing, here's my bar chart. If you make an Excel bar chart, your letters will go in the wrong order up that axis, because just that's how it does it. But mine does it all the right way. And then, you know, these charts are nice, but if you want to put a bunch of charts on the screen, they're too big. So let's see, I don't want the regular size. I'll go to a smaller size like this. Now I can fit more charts in there. And now I shrunk the charts, and the chart title is too big. So I'm going to shrink the font size as well. And there it is. And if you like different settings than I do, you can always come over here, click, and customize your settings. This is a busy dialogue, but it does a lot of neat things. And Ken, this is what I was talking about with the buttons that I changed. I made them work differently. So instead of, you know, the old-fashioned like 3D effect buttons that stick out, and when you click on them they stick down. No, when I click on it, it turns darker or whatever. You see, and you know, just neat stuff. Now, if
it's interesting.
If you let Excel make a bar chart for you, I was starting to tell this and I didn't show you the other great thing. So here's the Excel bar chart. Well, first of all, my chart, you see, it's taller than it is wide. It's a better aspect ratio for bar charts, but also mine goes, my labels are in the same order that they are in the sheet. And that's what people expect, but Excel always gives them the opposite order. But that's no big deal. I can flip my bar chart. See that button? Boom, there, it's fixed. Otherwise, you'd have to go, you know, you select this, you go Control-1, which is my second favorite shortcut in Excel, which opens up whatever the formatting dialog is for whatever you just selected. And you have to come here and you go, well, it's not, I don't want category, well, reverse order, and let's see, it's in the automatic. So this is how it is, and you have to come here and you have to change two things. You have to remember to change two things. Some people never discover those things, so their charts are always wrong. Or they'll come over here in the worksheet and they'll sort the data so the chart comes out right. And it's like, well, that's too much work. You know, we should have a little contest here. I just said my second favorite Excel shortcut was Control-1.
I was going to ask what your favorite was.
Yeah, what's my favorite?
This is where we get people to start firing things into the chat, right? And you get to pick one?
Yeah, I want to see a few guesses. Control-Shift-L. What does Control-Shift-L do? Alt F4?
It's obviously not your favorite.
I don't use a lot of oh, Alt F4. Yeah, I know what Alt F4 does. Yeah. So Control D. I use that frequently. I use Control W frequently.
So they don't rate as favorites?
No, I don't have too many favorites, and I actually probably use fewer shortcuts than a lot of people.
That's funny. I got to say, my two that I would have to say are probably my favorites are the Control Alt VV for pasting values and Alt F11 for opening the Visual Basic Editor. And the only
Yeah, well,
reason that I would say
I
that
use
is there isn't a
Alt
shortcut for
F11
power query.
all the time. No, my favorite one, and if you think about it, it might be your favorite one too. You just don't realize it. Control Z.
Well, I'd say it's my most frequently used, but that just if I say it's my favorite, that means that you know, then I just admit that I'm making mistakes, right?
Well, you know, Control Z, if you don't know, is to undo the last thing you did.
I believe, isn't the Microsoft data, doesn't it actually say that Control Z is the Control Z for us Canadians, Z for you, but I believe they actually have data to say that that is the most frequently used keyboard shortcut as well.
I'm not surprised.
Nor am I.
I say it's my favorite because it has pulled my bacon out of the fire a few times.
Control S. Come on, Carlos. Who actually uses Control S? You always want to use Control S right after Excel crashes. That's when you think about that one, right?
Yeah.
So it's the one that you should be saving. But honestly, I mean, with autosave today, I mean, that one is starting to become less of a concern, right? So.
Yeah, but see, I don't use autosave. I don't.
No, well, me either.
But so now another neat thing is I don't. You also some people you see their QAT and it's like chock full of buttons and it just gets too clogged. But I have my grid lines here things so I can clean up my sheet right at a moment's notice. I use the select objects because you know, I might want to select all of these charts and I go like that and I've selected them. Um, and switch windows, that's very helpful to have right here because Control Tab doesn't work reliably anymore. And I put the Save As up here. You know, a lot of times, if somebody buys my software, they need an invoice. So I go to my customer database and I spit out an Excel file. It's basically an Excel template that's their data. And so I save it with this button, and then I come here and I click Save As, and all I do is I come here and I find PDF, and now I've got a PDF I can send them. And it's so much easier, and it's so much nicer than going to Save As here, because Save As here, I don't understand what this is. I can't really tell what's going on. And, you know, I can still go here and find PDF, but oftentimes it doesn't, its default folder here is not what I would have expected it to be. So I stay out of this area of Excel as much as I can, except to come down here to, oh, and that was another thing that I added here. This thing, properties follow. Well, so in this case, they don't follow. What I'm going to do, I'm going to make a new workbook, and I'm going to use my little toolbox here, and I'm going to make a column chart. Okay, and I'm going to just play around a little bit here. Bear with me, and I'm going to make the data a little bit bigger, and I'm going to add this here. So now my data, what is my data showing? Oh, okay. So I messed up my data. So I have a button here that'll let me select new data very easily without going. Here's another dialog I hate. I hate this dialog. Select data. It's a very useful dialog, and I still just hate it. But so here's my data, and so what I'm going to do is I'm going to take those orange bars. In fact, I'm just going to take that first orange bar, and what I want to do with that first orange bar is give it a different color. I'm going to highlight it. So I'm going to highlight that first orange bar. And in fact, actually, the context that this is used in is, so what I'm going to do is I'm going to put some other data here. Sorry this has taken so long. I didn't have it all worked out yet. So I'm going to copy that data. I'm going to paste it here. And now what I'm going to do, you ever do this and you have one chart that's showing some data and you want to take a copy of that chart? And let me not make a copy of that chart yet. Let me add some custom formatting. So see, that that series, I'm going to make it a different color. So I'm applying custom formatting. I'm going to make that one gold, and I'm just going to select one of the blue ones, and I'm going to make it green. I'm going to use that nice bright green from down there. And so now I'm going to drag this over. All right. And now I want to use this data. I want to use this other data in that chart. So that's easy enough. I can, I can just drag those things over. That's the easiest way. And where did my custom formatting go? Where'd my stupid custom formatting go? And nobody at Microsoft will ever tell you what happened there. It's not documented anywhere. It's documented in a few web pages of people that ran into this problem and figured it out. What it is, you go to File and Options, and you go to Advanced, and you go about halfway down, and it says Chart. And this button here, Properties Follow Chart Data Point for Current Workbook. What does that even mean? You know, the one above it, it says Properties Follow Chart Data Point for all new workbooks. And you put your mouse over the I, and nothing happens. There it was. And it says, Properties Follow Chart Data Point for all new workbooks. Custom formatting and data labels follow chart points as they move or change in the chart. Okay. Still not sure what that means, but let's get rid of that chart that I ruined. And what I'm going to do now is I'm just going to move my data. I'm going to put some dummy data back over here. I'm just going to move my data by one column, and let's see what happens. See the yellow mark, the yellow series? It's not the middle one anymore, it's the first one. It's the one that's called beta. And in the left-hand chart, it's the one that's called beta. So that custom formatting sticks with the beta data. Oh, I'm a bad poet. And so that's what that means, that the properties follow the data points. I don't know how they could have said it better, but they couldn't have said it worse. So what you need to do is go back to this stupid place here, Options, and it takes you about, it feels like 5 minutes to get there, even when you know where it is. And Chart. So now you uncheck that thing. And now let me get rid of this chart, and I'll take this chart again. And now I'm just going to drag those things over. And now, because the properties don't follow the data point, my custom formatting didn't get all messed up. And so what I did is I added a button here where I can, well, it's still a little flaky. If I change my workbook, it figures out what it should be doing. Now it says it's, oh yeah, because I clicked it a few times. So, so that is supposed to save all the time of going deep into that's the old tools menu, right? The file options. This is another dialogue that I hate.
It's one of those awesome things where you look at it and you go, who chose to set the default that way, right?
Yeah, well, that's it. And fortunately, Microsoft has gotten good at figuring out what users don't like about stuff. And they set the oh, I don't have a pivot table here. Oh, you want to see a quick pivot table? This is just so I can do a demo in a hurry. I go click like this, and I have a table, a regular table, a pivot table, and a pivot chart. So anyway, a pivot table, right? When they came out and came up with a few other layouts for pivot tables, all these things called compact, outline, tabular. Well, tabular is the only one to use anyway, but what they did is, so people would learn about these other styles, they applied the other styles to your table. And the other style looks like this. And I guess in some context, that's fine. But most people didn't like that. And every single pivot table you made, you had to make it, and then you had to come over here and and get rid of compact, and then you had to get rid of your grand totals, and then you had to change all the other stupid things back to the way you liked it. And we realized that Microsoft has changed when, and I'm going to come back to this file options thing, but there's this data tab and this thing, edit default layout for pivot tables. And right in there, first of all, if you have a pivot table selected, it'll just take those as your defaults. But so now I set my defaults here, and every pivot table I make matches those defaults, and they might be different than Ken's because he has a different way of looking at stuff than I do. And when they came out with that, we realized, oh, these guys are really starting to listen to their customers. So anyway,
that was definitely a cool fix.
It was an awesome fix. So Ken, I don't know how you want to handle this, but I know you said that people can enjoy a beer, and I have to go down and get the crowler out of the fridge.
Yeah, you know what I think we're going to do is what I'm going to do is I'm going to stop the recording at this point in time. We're going to let Jon grab a beer so he can start hydrating here.
Yes,
and
that's right.
basically, so I'm going to turn the recording off now, I think. But hang on a second. We're going to stop recording.